Okay, we've got a 3-gram rubber band, 2.5 centimeter pullback, gives a 10 Newton force. So we've got a rubber band. It's 3 grams. This rubber band really isn't 3 grams. I'm going to assume it is. Okay? And we pull it back 3 centimeters and observe a 10 Newton force. Okay? Then I pull it back 1.5 centimeters and shoot it at a 45-degree angle, and there it goes, right? Okay? And I shoot it from a height of 1.6 meters above the floor. It lands on the floor 4.2 meters away. And my question is, totally off-the-wall question, what percent of the rubber band force appears to be conservative? Okay? Very hard question to answer in reality because there are all kinds of second and third order effects involved, like the rubber band hitting my finger and losing momentum, okay, and losing kinetic energy in the process. But anyhow, we want to, when we look at this, when you look at this at this stage, you probably have no clue about what in the world you're going to do to get to this, right? So what's the solution? Well, one part of the solution is just do everything you can with the information. There's plenty of stuff you can do with this information based on what we've learned, right? You don't worry about this thing. You just do everything you can and then look at what you've got and see if that could be somehow made relevant to this question, right? And then the thing that we always start with, that I'm really recommending here on the eve of the major quiz, is list the principles that apply in this situation. Answer the question, what's going on here? Okay? Don't immediately try to start plugging stuff into formulas until you get a picture of what's going on and remind yourself of the principles that appear to apply, right? And of course then once you think you have all the principles down, you start trying to analyze things. You might realize, okay, I forgot a principle. Well, you leave yourself room to add a couple, right? Because this gets you thinking in the way a good engineer thinks, or a good physicist, okay? Or any kind of a good problem solver. Organize the principles that apply and you move forward. Now there are different kinds of problems, and but a wide variety in all disciplines can follow the same model, which is why physics is often required for computer science, for most sciences, teaches a style of problem solving, okay? It's relevant to a very wide variety of disciplines. Okay, anyhow, there we are. So let's see what the principles are that you came up with, because what we did was we got into groups of 3 and everybody talked about their principles, and then we had various kinds of discussion, and at the end everybody took their eyes off the paper where they took the notes and told what they think the principles are, right? Okay? And I hope that kind of worked out well. It appears to have, but let's see what you came up with. Okay?